Hi, chemistry. So we're back, and today we're talking about the periodic table. It's going to be a brief introduction to the periodic table. We're going to talk about it in more depth and all the different parts, but first you have to know some of the basics. So, periodic table. It started out in the 1860s. A Russian scientist by the name of Dmitry Mendeleev. He organized the 60 known elements according to their atomic mass. Up until that time, there had been lots of arranging of the elements, but no orderly arrangement. So Mendeleev is given credit as being the father of the modern periodic table because he's the one that came up with the idea of putting them together based on their atomic masses. There was another scientist also working around the same time, but Mendeleev discovered his periodic table first, and so that's why he's given credit. The interesting and exciting thing at the time about Mendeleev was that he left some blank spaces for undiscovered elements. He said that based on the weights that he observed, there must be elements in between. So they didn't all go in orderly sequence. There were big sections where the atomic weights increased, and they went from, say, 10 and then jumped up to 25. And so Mendeleev said that because of that big jump, there must be elements in between that hadn't been discovered yet. And it was later found that as more elements were discovered, they fit neatly into Mendeleev's table. Then in 1911, a scientist by the name of Henry Moseley put together the current arrangement. And Moseley said that not only were the horizontal rows similar, the vertical rows were also similar. So they had common properties if they were going up and down or side to side. And so the periodic table that's on the wall in our classroom or the wall or the textbook is the one put together by Henry Moseley. Okay, so you know the periodic table is made up of individual blocks. Every block has a sort of secret code on it, and we're going to decipher that. You probably already know some of this, so if you do, just keep in mind what you don't know. Yes. So we have X. X represents the element abbreviation. Some periodic tables, like your reference table, will have the name of the element under the abbreviation. You might have noticed that the abbreviation doesn't always match up to the name that is given. That's because elements were discovered at different times, and some of the elements have Latin names, some of them have German names, some of them have French names, and so when it came time to standardize the periodic table, the committee, who's in charge of naming, decided that they would stick with the original abbreviations and they wouldn't standardize everything. So, for example, iron. Iron's abbreviation is Fe, and that's because it comes from the Latin word ferrous, Ferrous, and that's the Latin word for iron. And there are a lot of elements like that. Tungsten is abbreviated W for wolfram, the German name for tungsten. So you'll find that some of the elements are easily named and some not so easily named. The other thing that's inside the box on your periodic table is a number either in the upper right hand corner or sometimes it's in the center on the top, and that is the atomic number. There's no unit for the atomic number. The atomic number represents the number of protons that are in that element, and that is the characteristic that determines all of the properties for that element. If you change the proton number, you change into a totally different element. And then the last part is this thing that's represented by A. A stands for the average atomic mass. You'll notice that on our periodic table, the number is a decimal number, and that's because not all elements are quite the same, that there's variations. Just like there's variations in all of us, elements also have variations too, which we'll talk about in another video. Over here I have the example carbon is C. We just take the first letter, and then we have CO. CO is cobalt. So there had to be a way to distinguish cobalt from carbon that can't both start with the letter C. So the naming committee decided to take the second letter of cobalt, an O, and put it in lowercase, and that would be how you distinguish cobalt from carbon. So it's a little bit of better understanding of what the parts inside those boxes on the periodic table are. the periodic table, we have two main categories. We have groups. Groups are also known as families. They are the vertical rows, the up and down columns. And these groups they're elements that have similar properties, and the reason they have similar properties is because they have the same number of valence electrons. The valence electrons are the electrons that are located in the outermost shell. They are the electrons that are going to be doing all of the interacting. Also on the periodic table we have the rows. The rows are known as periods, and they are horizontal, so they're going across the periodic table. They also have trends, they also have patterns, but the trends are less general, they're more broad. So it's sort of like your extended family versus your immediate family. You're really similar to your brother and your mother, but you're not so similar to your cousin or your great nephew. So they're trends with certain characteristics, certain common characteristics. Okay, so here's a picture of a periodic table. There are no elements drawn in, but the basic shape, and so I want to go over the different groups and their names. So group 1, these are the alkali metals. The alkali metals are highly reactive, they're explosive, they are not found free in nature because they are so reactive. They're found bound up with other things. Then you have the alkaline earth metals. These metals are also rarely found free in nature because they're also reactive. They're not quite as reactive as the alkali metals, but they're very, very reactive. In the middle of the periodic table, we have this big giant section that's sort of below everything else. Those are the transition metals. Some of them are reactive, and some of them are very, very inert. So we have things like gold, which is right here, and then we have silver beneath it. Gold and silver are very, very stable, and they're found free in nature. They're inert, they are unreactive, and those are considered precious metals. Platinum is another one that's found free in nature because it's unreactive, and they're very valuable because of that. So these are our transition metals. Over here we have the halogens. The halogen are gases, and the halogens are also very reactive. They are non-metals, and so they're going to react with metals, which we'll talk about later too. Then we have the noble gases over here on the very, very far right. The noble gases are extremely inert. They do not react with any other element, and that is because they have a full valence shell. They have the most number of electrons in their outermost shell that they can hold, and it makes them very, very stable. Every element is working towards being a noble gas in terms of having a full number of electrons. So you notice that we have metals, metalloids, and nonmetals. So the right-hand side is made up of metals. The left-hand side is made up of metals. The right-hand side is made up of nonmetals, as you're looking at it. And then we have this big black line. That big, thick black line is the line that separates the metals from the nonmetals. Anything that touches that line is a metalloid, and that means that it shares some characteristics with the metals and some characteristics with the metals. So if it touches that line, it's a metalloid, or it's also called a semiconductor. And so those elements are sort of changeable in terms of, are they more like metals or more like nonmetals, and they can sometimes act as one or the other depending on what they're paired with. Down here we have 2 rows from the periodic table that actually come from this section here, and so to keep the periodic table compact, they've been kind of pulled out and they sit apart from the periodic table. These are the actinides and the lanthanides, and those are mainly synthetic man-made elements. And then, so this is our periodic table. We're going to talk in more depth about what the trends are, how they behave both vertically and horizontally, and we're also going to talk about what elements are made up of in terms of protons, neutrons, and electrons. Okay.